Thank you, everyone, for being here today. As Heinrich said perfectly, I'm going to introduce a subject that we work on, which is improving battery life of a mobile fleet. So first, a few words about me. I am Abdelmaunaïm Belghalem, as said again perfectly Heinrich, but people tend to call me Abdou for some reason. I am a technical consultant at droidCon, which is a sponsor for the event. Thank you again for everything. There I'm a roadmap developer and an onboarding consultant, which happened to be the reason why I'm here today, because being an onboarding consultant allows me to have to live the use case and be able to talk about them. droidCon is a tool and the company I work for, and the tool we used to make this happen and help developer improve the battery life of their application. This company is and the software is 100% eco-design core competency, which means our main purpose is to reduce energy consumption of Android application and mobile device applications. The tool we used during this use case I'm going to present to you is called the Power Test Cloud. It's basically the biggest tool in droidCon, which is a device farm that allows you to run your tests and UI tests or UI test or UX test, and be able to perform energy consumption measurement during those tests, simply using the Power Test Cloud. A quick outline of my presentation will be starting with the stakes of eco-design. Everybody knows here how much it is important for an application to be eco-designed and at least energy-friendly on the mobile device. And then I will talk of this in B2B and B2C environments. Then I'll start talking about the use case that we worked on, and from there I'll be able to give you some recommendations that we gave to the client ourselves. And I'll end with a short conclusion to be sure that you understood everything that I say and to be sure that you can write it down. First of all, the stakes of eco-design. The first category of application is the B2C, where eco-design is really important for one thing, which is user satisfaction. User satisfaction comes with an application that is performance, that has good performances, and that is battery friendly. If somebody uses your application and the smartphone starts notifying your application as over-consuming energy and resources, even if it's in foreground or background, this can mean that the user may uninstall the application or at least put some bad reviews on the store, and this is definitely not something you want to happen on your application. And there is another, if your application is really important for the user and you're lucky enough that he won't uninstall it or at least put bad reviews on the store, he will have user frustration, and this is something that you really not want to have when building your application, and you want to build a community on your application. In terms of B2B, it's exactly the same. User satisfaction is very important, but then again, there is one more point that is very important, which is productivity. In B2B domain, your application will be used by workers on their work hours. So if you make an application that is not battery friendly and consumes a lot of energy, your application performance will be less important, and therefore the smartphone battery life will be lesser than the worker's hours. Typically, this is what we are going to see. The application of the use case will be used for 8 hours a day, but if the application doesn't allow the smartphone to stay up and on for 8 hours, this is a big problem for user productivity. Of course, now we have solutions, hardware solutions, which are battery and battery and battery. A bigger battery and external batteries. We have a lot of solutions, but is it really the good solution when you know that it's heavier, it's bigger, it makes the device less mobile, which is which was his first purpose all the way along. So today I will show you that maybe adding battery capacity and adding an external battery is not the only solution that we have, and probably not the best one. For this, I will show you the use case that we worked on, which is basically the SNCF Cosmo project. SNCF is the main railway company in France. The application was for ticket inspectors in train. It was going from Windows Phone to Android phone. We arrived where they called us to start the project with them when they decided to move from Windows Phone to Android phone. So nothing was decided yet, but only Android platform. So we had to be there for them, first of all, with the device selection. They had a farm of devices. They had a list of devices, 5 to be precise, and those 5 devices were exactly the same for them. So we had to try and see which one was already a better choice for energy consumption. Then we helped them in the application development. So they used GreenSpectre, our tool, into their developments, into their CI, and it helped them decide everything every choice that they had to make in development to be the more user and battery friendly. They had, of course, an autonomy criteria because it's B2B, so the worker has to work 8 hours a day, which means if your application makes it that your phone, the battery dies in 3 or 4 hours, this is not a thing you want to have, because especially they are in trains, so it means that they either have to have another phone in their pocket to end the day, or a battery, external battery, which is heavier and not a solution. And of course, in the term of battery lifespan, this is very important because we're talking about 16,000 devices all through France. So it means that if the application is not battery friendly and consumes a lot of energy, you will have to change your cell phone after 2 years. If it is, maybe you can keep your cell phones for 5 years. So changing 16,000 devices after 2 years or 5 years is not exactly the same price. So we started to build a case scenario, which was simply how a worker used the application through the day. We summarized it to a certain number of features, which was barcode scans, RFID scans, and some network data. We think that network data is really important because in trains there are not only Wi-Fi or 4G or 3G, but sometimes they are in an area that is only 2G, and 2G can be and will be very consuming in a cell phone. So this is very important that we check also the network data. And then the idle, which is again really important. We see that there is 5 hours of idle in the day, which is basically when the train controller is speaking to a client, or again when he is launching the lunchtime at noon. So this is a time that we have to take into account. First thing was test automation, which is basically the only solution we have to be able to repeat the test on each device. So we used for this UI Automator, which is a tool that is in Android SDK, you can look at. And GreenSpectre API, which is Android API that we integrated in those tests. Basically 2 methods, start measure, stop measure. Everything between those 2 calls will be measured and sent to our server to draw a graph like this one. And of course, we tested on real devices that the SNCF railway company sent us. Those devices were 5, as I said, a Bluebird, a Zebra, a Copernic, a Famoco, and a Samsung. Of course, when they sent us the device, they already choose a little bit which one were their preferences, but they still had to choose between the Bluebird, the Zebra, and the Copernic. Samsung and Famoco were eliminated in terms of ergonomy. Then again, we tested the mobile network. As I said, in trains, there is not always 4G or Wi-Fi or 3G. A lot of the time it's 2G, and it's really important for them to know how much their application will cost in terms of energy during this trip and during this train trip. what we did basically was not to measure 400 barcode scan and everything that I showed you last slide, but a little bit less and take a sample of this and summarize it and then make a projection on a daily usage. So only 20 seconds of idle instead of 2 or 3 hours was simply enough. Repeated enough times, it was all good to project on a daily usage. The measure methodology was simple. It was making a reference measure, which is the device being on, nothing happening. This is the measure that we will use to compare with the other measures, because this is your impact. This is where your impact is going to be. The idle measure and the action measures are simply, as I said, the idle measure was idle on and idle screen off, and the action measure are the scans, credit card payment, and everything that, a train controller can do. Okay, let's start with the first recommendation here, which was device challenging. What we got when we started working was a Bluebird, and SNCF told us we have to choose between the Bluebird, which is X hour autonomy, like I think 12-hour autonomy, and this Zebra. And we're like, okay, but first let's try to see if it's really what the constructor says. Sometimes constructors says that there is 12 hours autonomy. In fact, there is a lot less. So for example, for the Bluebird, what we did notice was in idle measure, the CPU was always at 25% minimum. So it means that on the 4 cores, one of them was always at 100 because it was using some GPS location settings. Maybe it was done on purpose by Bluebird, maybe it was a bug. We never knew, because when we told them about it, they told us it was a bug. They sent us a new Bluebird, and it was all corrected. So every time you want to use a device for a new fleet, be sure to check everything that the constructor says, because it's not always as they predict. In France, we call this the Volkswagen effect. I don't know about this, I don't know about here, but be sure to check about everything that they say before using the cell phone for real. Second step, device selection. Once you did all the verification and the challenging that you could possibly think of, you have to choose between all the cell phones that are left, which were Bluebird, Zebra, and Copernic. Simple step. You measure each step of your application, each feature of your application, and you project on a daily usage, and you look at which cell phone is consuming the less. Simple enough. The next slide is my preferred one, because this is a graph that I love. Simple graph, indeed. All you can see, all the lines here are different configurations, as I told before. So one is with 2G, the other one with 3G, 4G, Wi-Fi, and with different brightness configuration. And we did this. These lines here are for the Bluebird battery, so the Bluebird cell phone, sorry. And our goal here is to arrive at 8 hours. So to make it simple for you, every line that ends up under the 0 line makes that the cell phone will have less than 8-hour battery. And we'll see that all the 3 lines that are with 2G network, all the other ones are 3G, 4G, or Wi-Fi. All the 3 lines that has 2G network are under battery, means that a cell phone will not last for 8 hours. Obviously, this is not a thing that eliminates the Bluebird, but you have to be able to know that. To know that everything that can be a configuration on the cell phone may affect your application behave. Nevertheless, even if the Bluebird was not able to stay 8 hours on with full 2G from the start, from the beginning, which is rarely the case, of course, it has been the cell phone that has been selected by the SNCF, because the other cell phones, even if it wasn't in 2G, some of the configuration, which were normal configuration, weren't able to last at least 8 hours. First thing first, when we choose the device and everything is set up, we have to choose if we want to use a MDM. And obviously, SNCF wasn't going to choose if they want to use. They told us we need one because everybody does. So why wouldn't we use MDM? What we said was maybe you should check again before before using an MDM, because MDM is not free. It's not energy free, it's not memory free. It's something that runs on the cell phone and drains the battery like all the other applications. There is no exception for it. So we started to measure without any MDM on the Bluebird, and then we continued to measure with Mobile Iron and AirWatch, for example. Here we measured for other MDM, of course, but what we can notice is that for without any MDM, is twice battery life is twice longer than with AirWatch. So maybe AirWatch is not the good call here. Maybe if you really want to use MDM on a cell phone, maybe you should check on your cell phone how does all the MDMs that you have that you can choose. Sorry, how do they behave on your cell phone, and then make the right call. If you really need the MDM, then maybe take the one which consumes the less. And try to see if you really need one, of course, but because always without the MDM will be always the best choice in terms of energy consumption, of course. After that, they had there is always a question that we are asked a lot when we are doing this kind of experiences and use cases, which is framework selection. Using a framework like Cordova in this example can be a lot of time gain and development time gain. So your development time will be less and less if you will use a great framework. But obviously, as I said, it has a cost. Using Cordova here, we see that the energy consumption, which is the two first lines, platform discharge and platform discharge speed, is more consuming, of course. There is more energy consumption, but the big point is the memory, which we saw that is going from 41 megabytes to 80 megabytes, which is the double. So again, Cordova will help you build your application faster. And of course, if you have a fleet that has Android and iOS and Windows Phone, you will have to build one code. But you have to know that this has a price, like everything else: energy price, and of course memory price. Of course, there is other solutions that exist, like Crosswalk, which is a plugin or framework, for Cordova, which basically replaces the Google view by another web view, which is less consuming. And for example, if you have to choose a framework selection and you do not have time to make it native for every environment, Android and iOS and Windows Phone, you can try to choose a plugin from your framework. So basically, Cordova Crosswalk was less consuming in terms of energy, but more consuming in terms of memory. So you have to balance and say, okay, I will try to reduce the energy consumption, even if it's use more memory. So framework selection is important, and you have to know that it has a price like everything else. When the application is built, it's not over yet, because you have to try to see which part of the application is consuming more. And of course, saying that the loading of the application is consuming more energy doesn't make it so simple, because the loading of the application happens, once, twice a day, maybe 3 times a day if there is 2 blocks in the day. But the idle parts are the ones that are always in the running. The application can be running for 8 hours straight, and most of the time it will be in idle. So reducing the energy consumption of idle phases is really, really important, and sometimes more important than the loading. If you have an application that you know that will be loaded once a day or twice a day, don't take too much time, don't use too much of your development time to work on the loading, and try to work on the phase that really matters, and which can be the idle. Last but not least recommendation, the network control. As I was saying earlier, cell phones tend to use a lot of battery in bad network conditions, like 2G or bad Wi-Fi, bad 3G, bad 4G too. And this is very important to know, that you can, obviously you know it, you cannot choose when your user is going to use your application. You cannot say that you should use my application only with a Wi-Fi, only with a 4G or 3G. you should be able to, but you are able with the Android APIs to detect that you are in a poor network connection and to detect that you are not in a connection state that will allow you to send your data properly. So what you can do is put your request in a buffer and say like, okay, now I'm in a bad position. I don't want to send my data, so I will try to wait until I have a good network. To finish, summarize everything I just said. A very important thing is device selection. Do not trust everything that people say and constructors especially say about the devices. When you do the choice, when you have a lot of choices of mobile, choose carefully to not be able to not find yourself with the bad device and already before the first line of code being already energy consuming. Software selection, which is framework selection, library selection. I didn't speak about it, but it's very important. Sometimes using a library is faster, but is it really worth it in terms of energy consumption? And finally, the user context control, which was, please be sure to check the network conditions before making any requests. Be sure that you're aware of the environment before doing something that needs that environment to work properly. Thank you for your attention. I'm a little bit late.
Thank you.